Okay, my name is Susie Newhan and I'm going to just briefly talk you through some examples of differentiating with fractional and negative powers. So let's start with some simple differentiating revision, just so we remember how to do it. Right, if we're going to differentiate y with respect to x, we would typically write it dy by dx equals, but we might also write it y prime. They mean the same thing. So as a reminder, this gives us the rate at which y changes as x increases by 1. So we think of it as the rate of change, we think of it as the gradient. Same things. Okay, so differentiation is all about multiplying the power by the number in front of the x. So we've got 5 times 3, 15x, and we drop the power by 1, 4. Okay, we're going to multiply 4 by a half. When we multiply a whole number by a fraction, we only multiply the top of the fraction. So we get 4 over 2x to the 3, dropping the power by 1. Now we're going to multiply 2 by 2/3. So we're going to get 4 over 3, drop the power by 1. We don't need to write that because it's implied with an x. X to the power of 1, it just means x. Now, if we have a term, and we went through this in class, if we have a term that has a constant times an x, we get just the constant. The x disappears if it has no power other than an invisible 1. And if there's just a constant before we differentiate, that completely disappears. Okay, so we've done it. So let's look at a completely ridiculous production function so that it looks a bit more like economics. So if we differentiate Q with respect to L, that's output or quantity with respect to labour, we get TQ over DL, but we might write it, whoops, Q prime, they mean the same thing. So now we're going to multiply 9 by 2/3, we're going to get 18 over 3 L to the power of 8, dropping that power by 1. Now we're going to get 8 over a quarter, L to the power of 7. Now we can simplify that, because 18 over 3 is 6, L to the 8 minus 8 over 4 is 2L to the 7. So now we get to the point of this video, which is when we're differentiating fractional or negative powers. So let's have a look at this. Now this we're not ready to differentiate yet because we've got some L's on the bottom. We don't mind numbers on the bottom, but we don't want terms that we're trying to differentiate on the bottom. So before I differentiate, I need to get everything to the top, and I also need to get everything in terms of a power. So none of these square root or cube root symbols. So this is where our knowledge of powers or indices comes in. So I'm going to rewrite Q, 5L squared doesn't need to be changed, but we have an L on the bottom. We can bring it to the top, but we have to make its index or its power negative. We can bring L squared to the top, but we need to make its power negative. We need to remember, therefore, that L to the minus 1 is equal to 1 over L, or 1 over L to the minus 1 is equal to L. So wherever the power is negative, it means that term really belongs in the other place. So here it's negative, so we can bring it to the top and make it positive. Here it's negative on the top, so we can bring it to the bottom and make it positive. So in this case, we had a positive on the bottom, so when we brought it to the top, we need to give it a negative power. Okay, we also need to know another rule of powers is that the square root of L is equal to L to a half. And the cube root of L is equal to L to 1/3. This is GCSE maths. If you don't know your powers, you really must learn them in any GCSE textbook. We went through them in 2 different lectures, actually. Make sure you know them. It's going to trip you up in future modules as well if you don't know your powers. Okay, so I'm now going to write square root of L as L to a half. So now we're ready to differentiate. So now I can write dq by dl, or q prime. And here we go. 2 times 5, 10 to L to the power of 1, but we don't need to write the 1. Right, now I'm going to multiply by this negative power, so my 2 becomes minus 2. And when I drop the power now, it becomes more negative. Minus 1 is minus 2. So we have to be really, really careful with negative powers. Now we're going to multiply minus 4 by minus 2. So we're going to get plus 8. L, drop the power by 1, it becomes more negative. Next, we have to multiply by this half. So there's an invisible 1 in front of the L. So we multiply it by a half. Now, what happens when we drop a half by 1? We get minus a half. If in doubt, stick it in your calculator. 1 minus a half is minus a half. So there we are. If we wanted to, we could put it back. Plus a half. Oops. 2 on the bottom. This is... you could always leave it like this in an exam. But if we want to take L to the minus a half, we can put it on the bottom where it becomes positive, and we can represent the half as a square root sign. Those are exactly equivalent. Okay, let's just do a couple more. So we're going to differentiate dq by dk now. So we're looking at another production function where quantity or output is seen as a function of capital, and we're going to be looking at the rate at which quantity changes as capital increases by 1. So here we go. We're going to multiply 5 by 2 over 15. We're going to get 2 over 15 k to the 4. We've got to remember that a square root is really k to the half. So I'm going to write it there. I should have done that before, really. Okay, so minus 3 square root of k is the same as minus 3 times k to a half. So we're now going to differentiate that. So we're going to multiply a half by minus 3. So we're going to get 3 over 2. Remember, we only multiply the top row of the fraction. And we're going to get k, and we have to drop a half by 1. So we get minus a half. Now we're going to multiply a third times 4, so we're going to get 4 over 3 to k, and now we need to think, what is a third minus 1? Well, it's minus 2/3. Use your calculator if you have to. But if we have a third of a pizza, and now we give, in some form or other, we give a whole one to a person, then we're in debt minus 2/3 of a pizza. Okay, and now we're going to multiply a third minus a third times minus 9. So we're going to get a positive number, because when we multiply 2 negative numbers, we get a positive. We get 9 over 3, and we now drop a third. We've got minus a third, we need to drop it by 1. So we're going to get minus 4/3. Again, do it on your calculator if you're having trouble with those fractions. So we can just tidy it up. 10 over 15 is the same as 2 over 3k to the 4, minus 3 over 2, I just got a message, minus a half, plus 4 over 3k minus 2/3, plus 3k to the minus 4/3. We could put these on the bottom if we wanted, because they've got negative powers, but we're not going to bother. Right, and another last question, just to remind us of some rules of indices. Sorry, we just need to simplify this a little bit. So when we multiply two numbers that are the same and they have powers, we can just add the powers. So here, oh, I made that hard on myself, didn't I? I'm going to make that 2 over 2. Let's make that 3 over 2. But we just have to add the powers, so it doesn't matter what it is. You can just use your calculator if you want to add the fractions. So so this is, we'll write it longhand, plus 3 over 2. So it's k to the power of these two powers added together. So we'll come back to that. Now, if I have something to a power inside a fraction and there's a power inside brackets and there's a power outside, you remember one of the rules of powers, and you must learn your rules of powers. We just multiply that number by that number. So here we are. K, that's the same as k 8 over 3. We multiply them together if they're in brackets because everything is raised to the power of 4, including that power. Here it's different, there's no brackets, we're just multiplying that by that, so we add the powers. Now, if we're dividing numbers that have powers, and the numbers are the same, that is, we subtract them. So now we're going to subtract 2/3 from 5/3. And we'll come back to that. And anything to the power of 0 is 1. So we can just write that as -2. So that got simple very quickly, didn't it? So now I need to just clean this up a bit. So whatever this 2 adds up to, in this case it's going to be, if we've got 1/3, 3/3, we've got a total of, 1/2 and 3/2, we have a total of 4/2, which is the same as 2. We have 4 over 2, that simplifies to 2. Minus k 8 over 3 plus 3 k, and now I have to subtract 2/3 from 5/3, so I'm going to get 3/3, and that's just 1. So we don't have to bother with that. In fact, we write that again, minus k 8 3 plus 3k minus 2, and now we're ready to differentiate. So dq by dk equals 2k. The power now becomes 1, so we don't bother to write it, minus 8 over 3k. We have to drop that power by 1. So 8 over 3 minus 1 is 5 over 3. Because 1 is the same as 3 over 3, and so we're subtracting 3 from 8, leaving 5. But if you're having trouble with fractions, do it on a calculator. Plus 3. So let's just do one more, and I'm going to make this up as I do it. So what if we have q equals, let's bring it down, q equals 5 to k to a half minus 3 times k to thirds minus 5k to the minus 2 over 5. So let's just make sure we can differentiate that, and then I'll put some practice questions up and some answers. So right, so let's differentiate. dq by dk equals a half times 5 is 5 over 2k. We subtract 1 from a half, we get minus a half. So now we're going to multiply 2 over 3 by 3, so we're going to get 6 over 3. Okay, we subtract 1 from 2/3, we get minus a third. Now we're going to multiply minus 2/5 by 5, we're going to get a positive number. It's going to be 10 over 5k. We've got minus 2/5, we now have to subtract 1 from that, which is the same as subtracting 5 over 5. So I'm going to get minus 7 over 5. So just tidy that up, we get 5 over 2k k to the minus a half, minus 2, 6 over 3 is 2, oops, yeah, 3, plus 2k minus 7 over 5. Okay, so stay tuned, I'll put some questions up and then I'll put some answers up. Okay, I hope that was helpful. And here's some practice questions. So if you freeze it, I'll put some answers up. Next. And here are the answers.